Welcome everyone globally, and thank you for joining this penultimate session of the Device Authority Virtual Summit 2024, themed around Zero Trust in the Era of AI. My name is Paul Lockley, and I lead our EMEA business at Device Authority, based out of the UK, and it's my pleasure to be the host of this next presentation. We've listened to many expansive discussions on cyber threat, AI and PQ, as well as the collective impact to industries such as automotive, healthcare, and critical infrastructure. And while Zero Trust is the new foundation stone of secure connected infrastructures, how do we also navigate the complexities of the journey ahead, particularly in challenging environments such as OT? So for this next session, I'm thrilled to welcome Danielle Jablansky, who is a veteran of our summits, and will talk today about OT heuristics, thinking fast and slow in OT. Danielle is an independent OT cybersecurity strategist and has researched global cybersecurity topics and OT and ICS cyber awareness throughout the industry. She's a non-resident fellow, a strategic advisor, and an adjunct professor. Her work has seen her researching and consulting for US government, Department of Defense, and many other large commercial organizations. She began her career with the Stanley Center for Peace and Security, evaluating cyber impact to nuclear weapons worldwide. And she contributed to the creation and development of the Stanford Cyber Policy Center at Stanford University. So a very warm welcome, Danielle, and let me hand over to you for your presentation.
Thank you, Paul, and thanks to the Device Authority team. I'm delighted to be here with you today. I'm going to jump right in, but before I do, I want to make sure people know what OT or operational technology means. At its grandest scale, operational technology encapsulates everything industrial and hyper-connected in facilities across the world, whether that's manufacturing, including things from automotive to pharmaceutical, conveyor belts, robotics, building control systems in the new fancy malls and stadiums around the world, and also things like water and electric utilities, which are very classic OT systems. So it does encapsulate a lot of different sectors. So when you think about OT and ICS, you think about cyber physical operations or processes that have control systems and computers that actually dictate and iterate all of the processes that go on in the control loop that actually backs the programming in which these machines and equipment function day to day in an automated function. So you'll also hear building automation or automation controls and instrumentation caught up in some of the jargon that I'm going to try not to use in today's session, but across the industry that's used writ large. OT cybersecurity has a lot in common with IT cybersecurity, although there are tons of differences. But today, when we talk about zero trust and artificial intelligence, the one big issue and complexity across OT and ICS cybersecurity is that just like for zero trust and artificial intelligence or machine learning algorithms, data and verification are key today to security. And from an IT standpoint, we have tons of data. From an OT perspective, we actually don't have that many attacks when compared to IT attacks. So of course, you can take IT data and look through OT networks to see if similar IT attacks are happening. But it's actually more prudent today to compare process data within the organization, within the environment, with some of the known IT attacks to basically combine things like predictive maintenance. And I'll get into what this means for the control systems themselves with the indicators of compromise from known IT attacks and a handful of very sophisticated and tailored OT attacks. The things that we look for in the data from an OT perspective are things like baseline configurations of control systems and their software, proprietary protocol understanding, and function codes. And so these are just some specific things that apply to control systems that are very different from IT. And another thing about control systems, when we think about protocols, again, for the most layman of terms, think about when you're driving a car and you can access internet on your phone and Bluetooth through your Spotify app and different things like that. Those protocols are all different and they're not typically the same protocols you would use to communicate via email. And so OT has its own host of protocols, and many of them are specific to the vendor that actually provides the equipment that's being used. So without further ado, we're going to talk about heuristics, thinking fast and thinking slow in OT, and how this predictive data and analytics in process control systems combined with security information and known indicators of attack and past attacks and compromises can actually be coupled together and married to build on things like AI tools for trust, verification, detection, and monitoring across OT environments. So why do we care about heuristics, and what really are heuristics? Heuristics are mental shortcuts that can facilitate problem solving and probability judgments. They're these snap decisions that we make, or the complex decisions that we thoroughly think through every single day. These strategies are generalizations, are rules of thumbs that reduce cognitive load and can be effective for making immediate judgments. However, they often result in irrational or inaccurate conclusions. So there is a bunch of psychological research on heuristics. There's a book by Danielle called Thinking Fast versus Thinking Slow. And one of the best examples of thinking fast versus thinking slow is before generations were living in modern society, there were hunter-gatherers. And if you were out in a woodland or a jungle or something like that, and you heard the rustling in a bush, like you see on the screen, you might think immediately your fast thinking would be for self-preservation. This might be a predator or a snake. And your slow, complex decision would actually tell you, no, this is the rustling of the wind, or you might think about other kind of contingencies. And so when we talk about cybersecurity, and especially artificial intelligence and the push for zero trust and verification across systems in this rapid, hyper-connected way of millisecond timing, we have to be really careful about what snap judgments get made and what types of complex decisions actually have the right backing and data sets for making better decisions. And so when people say that solutions or security should do more with less, I actually really hate that phrase, because we should be doing more with more. You need more data for these systems to be useful. So let's talk about really quickly some of the top risks to operational technology and industrial control systems. There's a use of legacy technologies with known and reported product vulnerabilities. You can Google the ICS Advisory Project, which lists a bunch of vendors and their respective software vulnerabilities for all of their equipment and manufactured products. Now, that doesn't mean that if Siemens pops up with the most amount of vulnerabilities, that Siemens technology is inherently more vulnerable than any other. It actually might mean that they have better researchers, or more products. So we have to be careful about this skew in that sense. And also there's a lot of different supply chain considerations when you think about the vulnerabilities in these products. And there's a lot of provenance questions about the kind of transaction of these systems and who touches them and which integrators kind of manipulate them or integrate them away from the vendor, and what kind of control we have over those processes. The second thing is the connectivity of control systems or process critical assets to other networks, which are sometimes inadvertently connected to the internet. So of course you can do a Shodan search. There's a lot of building management control systems on Shodan. There's a lot of other connected access items on Shodan. There's a lot of research around Las Vegas and the fish tank attack that happened there, and getting things off the internet. But again, you can't take these things at face value. If you find a control system on the, with some type of internet connectivity or access on Shodan, it doesn't mean that other compensating controls within that environment aren't protecting those devices. Number 3, an obvious one, which is very true for IT as well, but insecure remote access. We see that in OT quite a bit. We also see the hijacking of legitimate vendor remote access, which is sometimes disclosed and sometimes not disclosed, depending on the relationship with the vendor and, again, the integrator and the end user. The availability of equipment, machinery, and configuration specs online. So we've gotten a lot better at this as an industry within the process automation industry, but there are a lot of product catalogs, handbooks, configuration specifics, and things like that out there to help troubleshoot and help programmers program the software that is associated with all of these different vendor products and vendor-specific protocols and software products. However, that's the exact same type of knowledge base that you would need to then go and hijack these, utilize their native functionality, or figure out how to manipulate them in a malicious way. So that they're more and more behind a paywall, but that's still a consideration for security. Number 5, the lack of security controls or extension of IT security practices to OT and ICS networks. So a lot of end users in those sectors that I mentioned might not actually have an up-to-date asset inventory or a known list of all of their devices, what those devices communicate with, what exists on what network, the level of segmentation that they have in those networks. There's a lot of considerations of visibility and monitoring and different tools that just haven't really been extended into all of these hyper-connected OT systems and networks, as much as we would like to see today. And number 6, negligent insider threat, lack of change management and documentation. We actually see misconfigurations as a huge problem across the board, but the problem is end users can't immediately distinguish, or even in a couple of days sometimes, distinguish between a negligent error and an active threat. And that's really problematic, of course, for your incident response, for your containment, for your forensics, for your analysis, and for your whole IR cycle. So back to the data point that I brought up in the beginning, which, zero trust and AI and machine learning all rely on good and lots of data. There's an assumption that rules-based detections across environments have to do attributions where there are enough signatures and signals that allow cybersecurity teams to pinpoint where attacks come from. But for a lot of these reasons, and because these control systems are so varied and vast, there aren't a good amount of data that can perfectly match rules and signatures across these environments. So AI and ML in this case have to get a little bit more gritty, I would say, and a little more detailed into the process. So if that's the case, then what does the threat landscape actually look like if we can't copy and paste a ton of signatures or known tactics, techniques, and procedures, or TTPs? First, commodity malware, of course, including IT signatures seen in OT networks. Like we said, you can look for IT attacks across OT networks, and you will find them. There's a lot of good reports out there on this. Conficker, of course, the worm that won't die, since 2008 is still found on ICS networks, and there's a CISA report on that from the US. These are noisy, non-sophisticated, non-targeted attacks that kind of just see what I could do with a known IT exploit in an OT network, potentially, or even accidentally, that's kind of spilled over because of those segmentation issues we've talked about. There's credential access, weak credentials and passwords. There's often shared passwords or no passwords across the hardware and software that we use in control systems networks. Remote code execution, similar to IT. USB and transient device connectivity is huge in these networks because a lot of people have access to them for different things like technicians and programmers, engineers, etc. Lack of segmentation we already discussed. There's been a lot of destructive wipers, which are also often paired with credential access. If anyone is familiar with the blackout that happened in Ukraine, this is actually what happened there, was a pairing of two sophisticated exploits there that was able to worm through and caused a massive power outage for hundreds of thousands of customers there. Then there's tailored attacks on specific OEM products and their native functionality. The most recent example of this was called In Controller, where the attack was built in a way that the actual attackers could natively use the functionality of control systems as if they were legitimate owners and operators of those control systems. This one was caught before they were able to do that, but the complexity of the sophisticated tailoring of the three tools to the OEM products was more sophisticated than we've ever seen in the past. And finally, ransomware, of course, and cascading impacts to ICS and OT systems and process downtime. This was also made famous by a US attack known as Colonial Pipeline, where the actual exploit and manipulation was IT-centric. However, out of an abundance of caution and because billing was manipulated and lost, essentially, they did also shut down the pipeline operation, which caused a shortage of gas for a short time on the East Coast in the US. And it caused a public reaction and a bit of panic as well. So on this sliding scale, you see at the top over here, general hackers all the way to nation state capabilities. And you also see this sophistication scale from non-targeted, non-savvy IT attacks all the way to hyper-specific and tailored OT attacks. And I tell you all of this because the hyper-specific OT attacks are the ones we care about the most across these critical sectors: water, transportation, electricity, manufacturing, etc. Maritime is another one. But if we don't have a ton of data to go and find those exploits, because they don't always look the same, we have to get a little more creative in what we build into the machine learning. So if you can only alert and potentially catch on what you know how to look for in these environments, then you need to back up all of that security information data and your cybersecurity tools with process anomaly data. And that's really the what we're going to pinpoint today in this discussion around heuristics, is understanding how these systems are meant to work and being able to alert on when they are operating out of the norm, out of the baseline, pattern recognition. But that pattern recognition has less to do with communications data and inputs and more to do with process data from the actual system or control loops that are running. So there's tons of rules out there, tons of alerts. As we've covered, the reality is that no attacks look the exact same in OT and ICS. There's a frequent use of built-in tools and commands. There's the compromise of systems capable of communicating with field devices. This just means the instrumentation, the pumps, valves, etc., in the field that actually are the physical part of the cyber-physical communication exchange. and execution of attacks via legitimate protocols from a compromised endpoint. So again, very similar to IT, the effects are very different in OT, but the problem is threat detection is built on indicators of compromise. In OT, threat detection has to be fortified and solidified with process data, because these attacks that we know of do not provide the volume and telemetry of data to adequately derive common threat actor objectives and uniformity of these indicators to identify novel attacks ahead of time in OT environments. So what? Again, continued. There's a growing number of exploitable vulnerabilities in these control systems, which means that the number of potential attack patterns is growing, but there's 3 pitfalls. Companies are still mostly reacting to incidents rather than preventing their severity. Unfortunately, if no2 attacks looks very similar and you're kind of just looking for known knowns, you are waiting for other organizations to be victimized before you can potentially learn from what happens to them. And that kind of hope and pray posture isn't the best security posture across the board, especially for hypercritical resources and services that we need, like water and electricity and others. The numbering's off here, but the looming threat of highly sophisticated attacks, like we talked about for InController, which narrows the focus to threat hunting at the expense of other indicators worth investigating. So say you don't really know what to look for, but you've seen a similar attack targeting a similar company or a similar process. Maybe you then hyperfixate on USB attacks, but that might not actually reduce the risk level or profile in your environment because you haven't looked at other things that require some attention and analysis. And that's what some of the new AI techniques are looking at, how to then bubble up the most important actions you can take, updates you can push, things like that, so that you're actually reducing the risk landscape across your networks and your environments, rather than focusing specifically on preventing one type of attack or one TTP. And finally, data science in theory is useful for security, of course, but in practice, like I've said already, it doesn't solve for expertise in OT and ICS. Back to understanding baseline configurations, protocols, and function codes, you really have to pair that process knowledge or process data with communications data inputs, new nodes in the network, and who's sending commands to what and what those commands look like. So what's next? If we talked about heuristics, then intuition enters the chat. Intuition is the ability to acquire and apply knowledge and skills to understand something nearly immediately without full comprehension of the reasoning, and is considered the highest form of intelligence. So when we couple heuristics and intuition into AI products that go and scan networks in OT and ICS for changes, this type of intuition, again, comes from the process anomalies that you're able to detect across these networks. So say a specific vendor product from one OEM has a short list of associated function codes to read and write, send commands to field devices or instrumentation out there that's the physical part of cyber physical. Well, a lot of the machine learning now can actually say and alert on when a function code from one OEM is actually sent across for the wrong vendor product. So you see new anomaly detection emerging for AI across OT systems that can actually alert on process variable malfunctions or issues that we shouldn't be seeing. It also can do baseline things that we see across IT in terms of a user access from a location that's out of the norm, or an anomaly of timing for some type of control loop. They also have things across OT networks called historians, which are databases that actually have millisecond time stamps to assess over time the history of a process. And that type of data and analytics can also, again, be compared against security data to understand things like when a valve or a pressure situation is out of norm or out of band, or temperature or something like that. So again, assessing the anomalies in the actual process, in the environment, and the outcome of the physical side of these cyber physical relationships can actually indicate if something is being manipulated or something is wrong. It's similar to the process of predictive maintenance. And sometimes you can actually use systems that couple cybersecurity indicators or communications variables with process variables to do things like predictive maintenance. But also it's another stopgap with safety systems, which are required in a lot of industrial environments to actually say X temperature is an unsafe environment. So we're going to monitor the environment to see if this temperature is ever reached. And then we have a process for safely shutting down or safely halting the process. Same with chemicals for a water facility. There's external testing beyond the immediate process to verify or warn against the wrong or imbalanced amount of chemicals that gets put into that process. Similar one for things like that you wouldn't think of as cyber physical, but they are traffic lights. There's programming built in where you wouldn't be able to have traffic lights in some cases, depending on the vendor, be green in the same direction all the time, things like that. So these are different types of systems that are built to withstand changes and have redundancies built in. Some of those redundancies can be hijacked as well, but typically they're isolated. So it's a little bit more difficult to impact those systems at the same time as you have direct access to the operation of the system itself. Last example I'll provide is elevators. Actually, elevators have a lot of redundancies, even when they're connected, to prevent issues and impacts to human safety. So we've adapted our intuition to apply this context and situational awareness to understand, again, from the heuristics example, that noise from the bushes may be a predator, but it's more likely the wind. And you can apply that same type of thinking to the ML that you deploy across your OT networks to understand if a valve is spinning too fast, that could be a misconfiguration, but you also have enough data, depending on what tool you deploy. And I'm not pushing any tool here, but I'm just talking about what's built into that intuition. Depending on what tool you deploy, to actually go and investigate and pinpoint whether a change was made accidentally, whether an IP address was changed, whether somebody put in the wrong set point for that temperature or for that speed or for the different process variable that is running that component or that command. And that's really the future of where we're going across the detection space and how ML is already being deployed across OT. And we're also seeing that more and more in the access control side of things. So historically, access control for OT and ICS networks was a little bit behind because there were shared passwords, because there was so much vendor oversight over things and including access, and because we don't want to see a lot of interruptions to the processes that are sometimes 24/7. And so passwords have been kind of a lower level item on the security list of these networks, but we're seeing really innovative solutions there that do a lot of mapping and predictive analysis again to enhance that. I'm actually going to skip this one so that we have some time for questions and just talk a little bit again about what those variables look like in process analysis. So deep packet inspection allows for greater visibility into process flows of equipment in networks. And on the process side, we can track information such as minimum and maximum value. So the programmable value of the outputs like temperature, ranges, speed, water, liquid amounts, flow, all these variable rates, digital and analog inputs, last activity, number of requests, and number of changes. So a lot of the times you can actually even track configuration changes and things like that, which in control systems shouldn't happen very often. And that can actually be another key indicator. So with the new tools that combine a lot of the machine learning across communications inputs and indicators, looking for signatures for malware and indicators of compromise from TTPs of different threat actors, you can then marry that with this type of data and analytics to really understand if something has changed, was it nefarious? Can we pinpoint it? Can we contain it? Can we begin to do forensics and things like that? Can we run some scripts on these systems instead of just kind of looking into a black hole when we think about OT networks, what their configurations look like, what changes may or may not happen, and who has access? And before we jump into questions, my friend Emma Stewart and I wrote an article about this as well. It's specific to the electric sector examples, but if you're interested, you can go and look at this article. It's called "If I Have OT Detection, Why Do I Need Incident Response?" And it talks a little bit more about this marriage of cybersecurity indicators and signatures and process anomaly variables. And I have left about 5 minutes for questions, 6 minutes.
Super. Thank you very much, Danielle. I'll just give a little bit of time for people to pop some questions in. While I do that, I do have one of my own. As we see this sort of clash of desires within organizations where IT wants one thing and OT wants another, and invariably IT wants to see centrally and collaborate centrally, and OT says, not in my air-gapped environment, thank you. What do you see the biggest security challenges in transitioning that traditional OT environment into a more centralized, harmonious sort of platform?
So I have two answers. One is a process answer and one is a product answer. And the first on is planning. And so a lot of times you do see some of that pushback between coordinating, analysis and tools even. A lot of times you have IT folks that think that their tools are sufficient for OT, and it actually takes quite a bit of convincing otherwise. But that planning really breaks down if you start to ask an organization whose CISO or IT team still actually is responsible for any type of incident on the OT side. Okay, what's your incident response plan for a control system, for your PLCs, for these? And typically, if they haven't invested in interacting with those teams or doing that type of due diligence, they don't have OT specific plans and playbooks. And quite honestly, they look silly to their executives. And that then begins to help a dialogue or brown bag lunches and bringing in vendors and doing that type of analysis to understand who your guru is that understands ICS, who your vendor relationships are, what your integrator did, enabling or disabling certain security features when they brought the systems in, how old those systems are, what product vulnerabilities exist. That kind of expansion starts to happen. And what I love to tell folks and remind them when they haven't ever looked at OT is a lot of the forensic tools are the exact same. You use Wireshark, you use these similar IT tools. So I think you can excite people about the conversation instead of kind of degrading the conversation. And then I promise to talk about a tool. It matters what your OT SOC looks like. So some organizations have a person that is their OT SOC. Really hard job. Some people have a single tool that is their OT SOC. Some people have really, really high functioning combined SOCs. Some people have zero OT data analytic capability whatsoever. And so it matters if you're planning, how you're planning, and what your SOC capacity looks like.
So everybody's on a different rung of the ladder.
Definitely.
Super. So there's a couple of other questions. One is, what type of attacks on OT infrastructure do you think will become more prevalent in the near to medium future?
So I think we'll continue to see both the unsophisticated prevalence of IT attacks that, for lack of a better analogy, are things like throwing spaghetti at the wall and seeing what sticks, just because of the nature of the dark web and how easy it is to buy and sell credential access and exploits. But I do also think we'll see more homework being done about certain control systems similar to InController. Again, this knowledge is out there, and InController was a key indicator that a motivated threat actor or a motivated individual will spend the time to learn what that native functionality looks like, just like any ICS cybersecurity person today learning this industry is going to spend the time to understand what function codes look like, how to use Rockwell software, right, to program a PLC. If the information's out there and somebody's motivated to learn it, they're going to. And so I think we'll see both. I think we'll continue to see the spaghetti at the wall IT attacks in OT environments, as well as some more tailored and sophisticated things. But they do tend to be noisy. So they're not impossible to find, but you can't find something if you're not looking for it.
Yep. Excellent. One other question. How are CISOs looking differently at OT today, and how does that impact their perspective on zero trust?
Yeah, it's a great question. I have a very uniquely American view. However, I've looked into the NIS2 laws across the EU as well quite a bit. And CISOs today are recognizing that regardless of who owns what in their environment, they have to answer for a significant cyber event, regardless of which legislation defines that event. There's a couple of competing ones in the US right now, including the SEC rule for publicly traded companies, as well as the latest incident response law coming from CERCIA. And then in the EU, you might actually see member states create their own definition of what a significant incident looks like. So now every CISO is responsible for taking that definition, translating into both IT and OT attacks, looking at their prevention, looking at their insurance, looking at their tools and techniques, and publishing it. And then also a lot of these laws are saying, if you publish what you're doing and you're not doing that, you might be more liable than not for an incident. So it's really changing the ownership of the conversation, and it's increasing the visibility we see across OT and IC networks. We're seeing more interest in tools and diagnostics, understanding things like the MITRE attack landscape for ICS specifically. And in the future, I think you'll see, I mentioned it briefly in my presentation, but it's something I always talk about, which is the severity of impacts. It is your job to reduce the severity of impacts, and you can't do that by relying on other organizations to be victimized first. So it's one thing CISOs can do today, it's to be proactive about the severity of impacts and working to reduce the severity by catching things earlier and knowing where to look for them.
Great. Well, thank you so much, Danielle. I can't see any other questions that have come in, and I don't have any others myself. So I want to thank you for your time and your input and your presentation. For me, it was very well received. I'd like to take the opportunity to remind everybody that all of the presentations are available through online content through the BrightTalk platform, and to dial in for the last session, which will be hosted by James Penny, who will summarize and give closing thoughts on the half hour. And thank you for your commitment and time, everyone, presenters and audience, for joining our virtual summit.
Thank you very much.